Assalamualaikum and hi everyone. Chapter 4, Application of Differentiation. So in this video, we will focus subtopic 4.1, Gradient, Tangent and Normal to a Curve. Learning outcome for this subtopic. The first one is you need to find gradient of a point on a curve. The second one is you need to find equation of tangent to a curve at a particular point. And the last one is you need to find equation of normal to a curve at a particular point. Do you know what is gradient, tangent, and normal? So gradient at a point on curve is gradient of the tangent to the curve at that point. And to find the gradient of tangent, you need to find f prime x. Tangent is a line that touches at a single point and doesn't cross through the curve. So for example, if you have y is equal to x squared, so the graph is smiley like this. So tangent is a line that touches at a single point. So for example, if you have point A here, so tangent is a line that touches that point but doesn't cross the curve. So this one is tangent. Normal is the line that passes through a point and is perpendicular to tangent. So perpendicular means that line A and line B is 90 degrees. So this one we call perpendicular. So tangent is here. So our normal is 90 degrees and passes through that point. So this one 90 degrees. So this one is normal. Let's start with our first learning outcome. So we want to find the gradient of a point on a curve. So we have two steps in finding the gradient. The first one is you have to differentiate the function, or you need to find f prime x. And then second step is you need to substitute the value of x into f prime x. For example, find gradient tangent for fx is equal to x squared plus 6 at x is equal to 1. So the question asks you to find gradient tangent or gradient on a curve, so f prime x. So first step is you have to differentiate the function. So we have fx is equal to x squared plus 6. And then f prime x is equal to, bring the power to the front, so 2 and then x power minus 1. 2 minus 1 is 1. Okay, next you have to differentiate 6. So differentiate 6 will be 0. So f prime x is equal to 2x. And then second step, you need to substitute the value of x into f prime x. So from the question, you know that x is equal to 1. So at x is equal to 1, f prime 1 is equal to 2 times 1. So it's equal to 2. So therefore, gradient tangent is equal to 2. Next example, example 1. Find the slope to the curve fx is equal to 5x cubed plus 3x at point negative 1, negative 8. So the question asks you to find the slope. Slope is same as gradient. So means you have two steps in finding the gradient. So first step is you have to differentiate the function. So we have fx is equal to 5x cubed plus 3x. So differentiate f prime x is equal to, bring the power to the front. So 5 times 3 is 15, x and then power minus 1. So 3 minus 1 is equal to 2. And then differentiate 3x will be 3. So we have f prime x is equal to 15x squared plus 3. And then second step is you have to substitute the value of x. So we have point negative 1, negative 8. So this one is x. And then this one is y. So x is equal to negative 1. So f prime negative 1 is equal to 15 negative 1 squared plus 3. So it's equal to 15 plus 3. So it's equal to 18. Therefore, the slope is equal to 18. Example 2. Find the coordinates of the curve fx is equal to 4 over x plus 2x when gradient is 1. So the question asks you to find coordinates or x, y when gradient is 1. So gradient is 1. We know that gradient is same as f prime x. So first step is you have to differentiate the function. So we have fx is equal to 4 over x. Or you can write it as 4x power negative 1 and then plus with 2x. So differentiate the function. So f prime x is equal to, bring the power to the front. So minus 4x and then power minus 1 will be minus 2. And then differentiate 2x will be 2. So f prime x is equal to negative 4 over x squared plus 2. And then from the question, we know that gradient is equal to 1. So you just have to substitute f prime x with 1. So you have 1 is equal to negative 4 over x squared plus 2. And then you have to rearrange this equation to get the value of x. So first bring 2 to the left side. So 1 minus 2 is equal to negative 1. So minus 1 is equal to negative 4 over x squared. And then x squared to the left side. So negative x squared is equal to negative 4. And x squared is equal to 4. So we have square here. So bring to the right side will be square root. So x is equal to plus minus square root 4. So x is equal to 2 and x is equal to negative 2. The question asks you to find coordinates. So you have to find x and y. So to find y, you just have to substitute the value of x into fx. So when x is equal to 2, f2 is equal to 4 over 2 plus 2 times 2. So it's equal to 2 plus 4 equal to 6. So the first point is 2, 6. And then when x is equal to negative 2, f negative 2 is equal to 4 over negative 2 plus 2 negative 2. So negative 2 minus 4 is equal to negative 6. So the second point is negative 2, negative 6. Next example, example 3. Gradient tangent of a curve fx is equal to ax plus bx squared at point 1, 2 is 1. Find value of a and b. So the question asks you to find value of a and value of b. So it means that you have to find two equations and then you will solve simultaneously. So first information is you know that gradient tangent at point 1, 2 is 1. So gradient at point 1, 2 is equal to 1. So we know that gradient is f prime x. So f prime x, x is 1. So f prime 1 is equal to 1. So that is our first information. So first step, you have to differentiate the function. So fx is equal to ax plus bx squared. So f prime x is equal to differentiate ax will be a and then plus bring power to the front 2bx and then power minus 1. And then we know that f prime 1 is equal to 1. So f prime 1 is equal to a plus 2b times 1. So 1 is equal to a plus 2b. So this is the first equation. The second equation is we can get from this point. So we know that x is equal to 1 and then y or f1 is equal to 2. So we just have to substitute x1 and y2 into this equation. So 1, 2. So f1 is equal to a times 1 plus b1 squared. So f1 is equal to 2. So 2 is equal to a plus b. So this is the second equation. Okay, next you have to solve simultaneously. So we have two equations. So equation 2 minus equation 1. So 2 is equal to a plus b minus with 1 is equal to a plus 2b. So 2 minus 1 is equal to 1 and then a minus a 0, b minus 2b is equal to negative b. So b is equal to negative 1. So to find a, you just have to substitute b is equal to negative 1 into equation 1 or equation 2. So I choose equation 2. So 2 is equal to a plus minus 1. So bring minus 1 to the left side. So a is equal to 3. So therefore, a is equal to 3 and then b is equal to negative 1. This is exercise for you to do. If you have any question, you can ask your lecturer. Thank you.